All right, so we've been looking at forces on an object on a slope, and then we looked at forces exerted by a spring. We are going to combine these two things together. We have an object on a slope pushing on a spring. Sounds complicated. Really, it's not. All of these equations are pretty basic. The trig is still pretty easy. I'm going to remind you of that if you've been practicing, this isn't anything new. It's nothing hard. There's several steps. That doesn't make it complicated. All right, so starting off with, we're on Earth, by the way. My object here is 20 kilograms, okay? It's on a 40-degree slope, and it's compressing a spring by 2 meters. This is a huge spring. My final goal, the final thing I'm looking for, is the spring constant for that spring. So before I learn that spring constant, and the spring is in line with the slope, I need to know how much force is pushing on that spring. So starting off with, I know I'm going to need to find out what's the force kind of in that direction. If I'm doing this right, oh, that's horrible. That's okay though. That's a right angle. That's 40 degrees. I know that straight down, that's my force of gravity. That's not going to help me because it's not all of that mass, all of that weight, all that force. Not all of that is going down the slope. Okay, some of it's going off in what we call the y direction or into the slope. The rest of it kind of coming down the slope, F of g, or force of gravity in the x direction. So this, I need to find this first in order to find out the force on the spring. Okay, I need to find this first. So, okay, I need to find that. So starting off, to find F of g, if I know, I don't know force of gravity yet. All right, so let's figure out force of gravity is equal to mass times acceleration due to gravity. So in this case, I have 20 kilograms times negative 9.81 meters per second squared. Let's see, 2 times that is 9. Okay, 2 times that should be 19.62. I'm going to guess it's 196.2 newtons. All right, let me double check that actually. Let's get a calculator up here. All right, so 20 times it by a negative, that's fine, 9.81, whatever. 196.2, good enough. All right. So that's my F of G. That's in newtons. Okay. Let's see if I can draw this one a little bit better. Yeah, that looks better now. All right. I'm not going to care about FG of Y for now, or for this whole video. All right, FG of X. This is what I'm looking for. I'm looking for the opposite side. All right, so FG of X is going to be equal to that hypotenuse times, if I'm looking for opposite, if I use my trig, SOHCAHTOA, sine is opposite over adjacent, that's what I want. Times it by the sine of 40 degrees. And we'll do that. All right. So now I know what I'm typing in. Let's see if this gets me a good answer. All right. So let's go C. Let's go 40 sine times 196.2. I just need to make that negative, so negative 126.1. Assuming that's right. All right. That's my FG of X. That's how much, if I'm just looking at my spring. You know what? Let's even look at it as if it's horizontal. Okay. 20 kilogram. And if we're saying it's going to compress the spring 2 meters, all right. I know that if I'm pushing in with negative 126.1 newtons, the spring must be pushing back with kind of the same number, just with the opposite sign, okay? So I know the distance the spring's moving. I know the force being exerted by the spring. So let's go. So force of the spring is equal to spring constant change in length. All right. So I know the force of the spring, 126.1 newtons. Whether you put that negative or not doesn't matter. Equals negative k or just k. We know the change in length is 2 meters. I just got to get k by itself. Divide by 2 meters on both sides. All right. K is equal to, I'm going to guess this is 63.05. All right, and my unit here is newtons per meter. Let me double check my work there, bring up the calculator again. All right, 126.1 divided by 2, 63.05. All right, that right there is my final answer. And that's really just taking, like I said, it's nothing new. It's just taking what we already know and just kind of mushing them together to get, I mean, essentially it's still looking for force. It's just about realizing that Fg of x, in this case, is pushing down on the spring kind of angled the same way. So now your question is, why on earth would we ever need that? Essentially, this spring could be like a stretchy rope or could be like part of a trebuchet. Also, these calculations would be used for things like pinball machines, stuff like that. Or going back to like mechanical engineering, setting up the plans for like a factory. There's times when you may need to use a spring to like cushion a fall, and then send it, down along a different pathway, stuff like that. Anyway, I just thought to go through a quick example. Good luck with the practice problems.